Let me start with a personal story. I've been a fan of fossil energy since my childhood. I know it's very polluting. That's why we are here. We want to have a renewable future, but there is a reason that I have been a fan of fossil energy. The reason is that fossil fuel stores a lot of energy. For part of my life, I grew up in India where there was hardly any electricity. And one of the main reasons I'm standing in front of you as a scientist is because of fossil fuel, kerosene. I could use it in my lantern and in the night and study. The reason I could do it is because it stores so much of energy and you can use it anytime, anywhere you want. One of the main reasons, apart from the cost and other things, fossil fuel has survived for so long as a technology is because of its ability to store a lot of energy, and that gives you significant flexibility. You can use it anytime, anywhere, whether it is rainy, shiny, it doesn't matter. Say here in our country here, we use it for heating our home, driving our car, get our electricity. So the question is, can we do the same thing? Can we get the same flexibility with renewable energy? And why it is very, very important is because we do not have any control over renewable energy. First of all, there is no sunlight in the night. Imagine a future where you have significant amount of your electricity is coming from solar panels. What are we going to do in night? That's one big problem. Second problem is that, as you can see on the graph, there's a lot of fluctuation. The electricity that comes out of the solar panel fluctuates a lot. There could be many reasons. It could be a rainy day, there are cloud covers, and whatnot. So the question is, what can we do to make renewable energy on demand? That requires a significant breakthrough in storing energy coming out of a PV panel or a wind turbine. There's another reason why we want storage. This is the data that I'm showing you from California, came in the month of March. It is a matter of pride for us as Californians that for a couple of days in March, more than 50% of the energy came from solar. However, during that time, the price of electricity went negative. There were no takers. And that's not an economically viable technology, right? And the reason there were no takers is because actually we use the energy in the later part of the evening and we generate most of the solar energy around noon. So again, if we have storage or we can store that energy, then you can imagine a future where we can use it later in the later part of the evening. But the challenge with storage is that, let's say we want on-demand flexibility, right? We on-demand availability of energy, we want it anytime, anywhere. So today with photovoltaic panels or solar panels, you don't have that flexibility, but the cost of the energy is already comparable to that we get from fossil fuel. However, if you put a battery on top of it to get this flexibility or on-demand availability, then the cost suddenly goes up quite a bit. So the challenge for the scientific community is how to develop technologies to bring that cost down so that renewable energy becomes very, very flexible and available anytime we want. And that's what we have been doing at Berkeley Lab, actually almost for 50 years, more than 50 years. A lithium-ion battery, which a lot of you are familiar with, is used even probably in all the computers and probably in this clicker. The work in lithium-ion batteries started in Berkeley in 1954 by Professor Charles. And it has kept on evolving from there, and we have started doing quite a few other different things. But the vision that we have at Berkeley is discovery to devices. So discover new materials and use those materials to make new storage devices. And one of the latest and greatest things that we have started doing in recent years is to start discovering materials on computer itself. So rather than going through a lot of experiments, time-consuming, very expensive experiments, we can do many of these experiments on a computer and figure out the right kind of material which will give us the kind of features that we want in a storage or a battery. We also synthesize those materials. So we discover these materials on the computer, then make these materials, and then characterize them, understand the physics and everything. And finally, we make devices to understand how will these devices perform in real world. Are they going to be reliable or not? So with all these things that we are doing at Berkeley Lab, what we are hoping sometime in the future, as I showed you earlier, that there is significant fluctuation in the power coming out of the PV panel or even a wind turbine. Sometime in the future, we will have a very nice control on this power coming out. And rather than a power coming out like this, hopefully we'll have a nice flat line which we can control as much as we want. Thank you very much.